My name is Nicholas Lopatine, and I will be talking about innovating solutions using augmented reality tracking and localization. First, a little bit of background about me. I've been fascinated by technology since a very early age, and in elementary school, I was first introduced to 3D tools for the purposes of creating art projects. I thought it was really cool, but I never really got hooked by 3D until middle school, when I was exposed to how 3D tools could also be used to create practical projects, for instance, 3D printing things. In high school and in university, I moved more toward creating 3D animations and interactive 3D and augmented reality experiences. And I realized that augmented reality has great potential for both artistic endeavors and practical problem solving, much like what I love about 3D. Augmented reality also enables a lot of use cases that traditional technologies can't enable. And underlying augmented reality's ability to provide value in such a wide variety of applications are a number of technological breakthroughs that enabled AR tracking and localization to run on the processors of mobile devices, which is really where AR is most practical. Now, I've been talking a little bit about AR, and I think it makes sense to give a little bit of context about where this falls within what really encompasses it, which is called XR, or extended reality. XR is an umbrella term which actually includes a couple of different technologies: AR, VR, and MR. AR stands for augmented reality, and augmented reality augments the real world by digitally adding visual elements or adding audio and haptic feedback. This is in contrast to VR, virtual reality, which replaces the real world with a digital environment instead. AR is also very similar to MR, mixed reality, which has more emphasis on spatial tracking and is typically applied to headsets. In 2024, there are a number of AR-capable headsets that have been released recently, with understandable hype surrounding the innovations and technological advancements they have made in recent years in terms of display technology, chip performance, and software for environment, hand, and eye tracking. These devices allow users to seamlessly place 3D content in their environment and access an additional level of context on the things around them. On the left-hand side, you can see the first two columns show two devices which utilize pass-through video and pass-through AR, which means that there are external cameras that are able to feed in a visual feed which has some additional elements overlaid on top of it digitally using augmented reality. The four devices on the right-hand side, starting with the Microsoft HoloLens 2 and going to the Meta Orion on the right, they utilize see-through AR, meaning that their lenses are actually transparent. They don't display a camera feed on an internal screen, but instead let the real world shine through the lenses and then shine additional AR elements on top of those lenses. While all of the headsets have their own pros and cons, and some, like the Magic Leap 2, tick almost all of the boxes for a mixed reality headset, although at the surprisingly consistent high-end headset price of around $3,500, the typically unacknowledged silent workhorse of mixed reality is actually the smartphone. Nearly everything that mixed reality headsets can do, and more, can be done by the smartphone. And, very conveniently, most people already have smartphones in their pockets. This is an animated GIF that I made of my iPhone 12 mini, a 3D model that I had found and I was able to actually animate as well. I'd like to show a couple of different projects that I have developed using augmented reality tracking and localization to give a sense of what is actually possible to be done with it, why it is capable of both artistic projects and practical projects. Starting with practical projects. The first project I'd like to talk about is SU Maps, which is an augmented reality navigation app for both iOS and Android that I developed with my team for my senior design project at SCU. When I first came to SCU, I was much like these two poor guys on the left-hand side, struggling to find different locations on campus due to a variety of issues with campus signage and online campus maps. In order to resolve these issues, my team and I, after discussion with lots of other students and faculty and staff, decided that we would like to build an augmented reality navigation app, which would enable people to actually just point their mobile phones at their environment to recognize where they are, and then be guided with augmented reality arrows that were placed on top of their camera feed to their destination. In the middle, you can see a GIF of a Matterport Pro 3 3D scanner, which is what we actually use to scan the buildings. On the right-hand side, you can see one of the processed 3D models of the buildings. This one is Heaphy Hall and Bergen Hall, which are two adjacent buildings on campus, which are pretty notorious for being difficult to navigate. Here, you can see a screen recording of our app being used. When you first launch into our app, you're greeted with the ability to select a destination from a drop-down. Here, I'm going to go ahead and select Heaphy 238, which is upstairs in the second floor of Heaphy. I'm starting outside of Heaphy Hall, and at this point, the app is starting to look for features in the camera feed, which it recognizes. Since our scan includes the indoors as soon as we come inside, it's able to recognize those features, figure out where we are, and based on that, place augmented reality arrows from where we are to the destination. As we get closer, those arrows fade away, and we can already see that as we enter the atrium of Heaphy, upstairs there are arrows pointing out where we're going to be going. As we turn towards the stairs, the arrows change direction and also tilt to point upwards. And as we continue around, I'd like to point out that this location that we chose is actually only one of 126 different destinations within Heaphy and Bergen Hall that we could have selected. As we round this final corner, we can see that these last few arrows are going to fade away, and at the end, we'll be able to see a bouncing destination icon, indicating to us that we have arrived at our location. If we check what location this is, by the nameplate next to the door, we can see it is in fact Heaphy 238, just like we had selected. From here, if we wanted to go to any other destinations, we'd be able to just select from the drop-down a different destination and use our augmented reality navigation to get there as well. One of the really awesome things about this is that our app is capable of not only indoor localization and tracking, but also outdoor localization and tracking. So here you can see two images, one in the daytime and one during the nighttime, of augmented reality localization working on a mobile device. While AR can be used for practical projects, it is also very useful for artistic projects. The first artistic project I have is actually also a practical project, because this was something I was working on with a faculty member. We were designing a tree to actually be physically made for a film project. And in order to get a sense of what that tree looked like, rather than just being on a 2D screen, we wanted to put it into augmented reality to be able to see it a little bit better from different angles. You can see on the right-hand side is what it actually looks like in AR. But in order to get there, we have to use the left-hand side, which is a 3D AR viewer that I created, a website, where you can actually go and spin the tree around, zoom in, and view it from different angles, and then press the button on the bottom right corner of the screen to launch into AR. The benefit of this AR is that we're able to deploy this tree so that it can be on a variety of different surfaces in a variety of different sizes. For example, the middle screenshot shows that tree being placed on my keyboard. But on the right-hand side, as mentioned before, that tree has been scaled up to a much larger size so it can actually be on top of a lawn. All of this works using a technology called SLAM, which stands for Simultaneous Localization and Mapping. What this means is that unlike in the SU Maps app, where we had previous knowledge of what environment people would be using our app in, and therefore were able to recognize that environment from their camera feed, here, the app is actually basing where to place the objects off of a map that it's creating while it is moving through space. So it's able to both map and localize to this new environment at the same time. The next project I'd like to show is the Christmas tree AR experience that I created. Unlike in the last project, where the tree itself was a virtual tree being placed using augmented reality, in this case, I'm placing AR ornaments on top of a real tree. You can see here that when I point my phone towards the tree, it's able to recognize that tree based on a scan I had taken previously and place augmented reality ornaments on top of the tree. I've also made a number of informational projects and product showcases, which is another area that augmented reality excels in. For instance, this project allows people to learn a little bit more about a mechanical pencil. Here you can see that in augmented reality, the user can tap on the pencil to expand the pencil out and show all of its internals to learn a little bit more about how mechanical pencils work. While we can track the world, either based on a previous 3D scan or based on the SLAM technology that I mentioned, we can also track image anchors. This project is a poster experience that I created for my senior design project. On the left, you can see an image of the poster, which has no moving parts because it's printed on paper. However, once you scan a QR code and point your phone towards that poster, we can see that there are additional augmentations placed on top of it using augmented reality. For instance, a destination icon on top, and the whole entire right panel of the poster is replaced by a video, enabling people to see what the app actually looks like. Here you can see a video of how it works. First, we start by looking for the QR code, and then once we scan it, we're brought to an AR viewer website, which means that people on different devices can access this experience. It indicates where we should point towards, and once we do, we can see that destination icon on top bouncing up and down, and the entire right side of the poster has been replaced by a video of our app experience. Another cool part about the AR experiences that I've built are that some of them are able to actually be shared via social media. So this is a project that I created for the UCCE, the University of California Cooperative Extension, to educate people about composting and reward people who have composted. In this AR experience, you can actually place a compost pile, 3D model, in your own space, which has grass growing out of it on top, which blows gently in the wind, as you can see in the GIF on the left-hand side. If you tap the I composted banner at the top, that will drop down and enable you to switch to the selfie view, which enables you to take a picture or a video of yourself with the I composted banner above, and then share that via social media. In addition to these experiences, AR is also capable of other types of tracking, for example, facial tracking. In this experience, I created a virtual try-on for the Apple Vision Pro for people who were not able to actually go and visit an Apple store, for example, in person to try it on. This gives a sense of what the Apple Vision Pro might look like on someone's face and tracks their face using different sensors that our phones have. For instance, you can see those videos right there showed a depth map and a mesh being placed on top of the face, which were indicating where the person's face was and allowed that Apple Vision Pro to be placed there consistently. One exciting thing is that some of the extended reality tooling that exists allows you to deploy to a variety of different targets. For instance, to AR devices, VR devices, and mixed reality devices. This experience was something that I created during COVID, when many people had to wear masks for extended periods of time. For healthcare workers, this was especially important because the masks wrapping around behind the backs of their ears would often irritate the skin and create friction lesions, which would allow infections to enter the body. In order to resolve this, I created a 3D model of a mask ear protector, which works by allowing you to hook the mask around the back of your neck to this mask ear protector instead. There were two different versions, and on the left-hand side, you can see another 3D viewer website which I created, which enables you to switch between these two different options, the 2 and the 3 hook version, change colors, and in the end, place this in augmented reality using your mobile device to get a sense of what it would look like before you decided to 3D print one yourself. The awesome part of this is that this experience doesn't only work on mobile devices, but also works on headsets. For example, here you can see it on the Meta Quest 3. I'm able to view the same web page in the browser on the Meta Quest 3, switch between the two different versions, the double hook and the triple hook version, change colors, and launch it into augmented reality using the headset. At this point, I can scale this up from its actual size to make it a little bit larger and easier to see, and interact with it using hand tracking, which is another important part of mixed reality. I'm very excited to continue to build innovative solutions using augmented reality and other XR technologies. If you'd like to try some of these experiences for yourself, there are a couple QR codes here for the mask ear protector experience, the social media shareable AR experience, and the AR poster experience. For the AR poster experience, once you scan that QR code, you can then point your phone towards this poster in order to see the experience itself. Thanks for watching.